RHS Pre-Calculus presents Solving Aviation Problems in High-Stress Situations. It's a national emergency. Lois Lane has been kidnapped by Lex Luthor. Superman jumps into action, but looks. Lex has put her in a diabolical trap with a giant fan. Can Superman do aviation problems during a time of crisis?
Of course I can. I'm Superman, the Man of Steel. I can do any math problem I want, and so can you with some training. Here, let me help, along with some of my math analyst friends. Let's first look at the basics of aviation problems.
An aviation problem is generally solved in a Cartesian plane. Unlike normal problems, however, the directions are rotated 90 degrees, with north being 0 degrees and east being 90 degrees. Within an aviation problem, you will be given several pieces of information.
The first thing you'll be given is a speed, generally in miles per hour, kilometers per hour, or knots. This is your magnitude. The second piece of information is your bearing, given in degrees. The other part of the problem consists of a wind of a different magnitude and direction. In this case, Superman needs to fly due north, traveling at 100 miles an hour. However, the giant fan is blowing from 55 degrees at 30 miles an hour. What should Superman's true heading and speed be?
Let's put this all together. First, plot your bearing on the plane, giving your path the magnitude and proper direction. Next, do the same thing with the wind. Your finished product will look like this. We have labeled all the necessary angles and magnitudes. Now we can start solving the problem.
We can use the law of cosines to find the magnitude of our true heading. The formula for the law of cosines is a squared equals b squared plus c squared minus 2bc cosine a, with b being our wind velocity and a being our wanted velocity. The angle a is the angle opposite our shifted course. In this case, our formula is 100 squared plus 30 squared minus 2 times 100 times 30 times the cosine of 125 degrees. When we work this out, we get a true velocity of 119.76 miles per hour.
Next, we use the law of sines in order to find our true bearing. The formula to find the wind correction angle is wind speed times sine of A divided by true velocity equals the inverse sine of the wind correction angle. In our case, that's 30 times sine of 125 degrees over 119.76 equals the inverse sine of our wind correction angle, which gives us an angle of 11.84 degrees. Since we're heading due north, we don't have to subtract our wind correction angle from any other angle.
In order to counteract the fan, I have to adjust my course accordingly, traveling 119.76 miles per hour at 11.84 degrees. Let's go.